Welcome back. Myself, Dr. G. Prasanna, working as an assistant professor in the Department of Genetics and Plant Breeding at School of Agriculture, SR University, Warangal. Today, we'll discuss about the most important topic, that is breeding for sorghum, bajra, and ragi. As we know, these are the most important millets. That is sorghum, bajra, and ragi are the most important millets which are highly nutritious and which are having the high fiber content and low glycemic index. If the glycemic index is low, it is good for the diabetic patients. So these millets are having so many benefits, and they are having the low cholesterol, low fats, and they are having the high fiber content. So today we'll discuss about this most important topic, that is about the breeding for the millets, that is sorghum, bajra, and ragi. So here you can see the list outlines, that is the centers of origin, distribution of the species, breeding objectives, conventional approaches, and innovative approaches. The first we will discuss about the sorghum crop. The sorghum is the most important millet. The scientific name of the sorghum is, it is a sorghum bicolor, and it belongs to Graminae family, and it is having the chromosome number 2n equal to 20. The chromosome number, it is also a diploid species having the chromosome number 20, and it was originated in the Southeast Africa. So this is about the introduction of the sorghum crop. First, here we can see about the introduction. The first is the centers of origin. Generally, it is accepted that Ethiopia is the centers of origin for the sorghum crop. And next is distribution. First, we'll discuss about the global distribution. That is the major sorghum growing producing countries are Africa, India, China, Pakistan, USA, Australia, Argentina, and Mexico. These are the major sorghum growing countries. Next is at a national distribution. Whereas in India, the major sorghum growing states are Maharashtra, Gujarat, Tamil Nadu, Karnataka, Rajasthan, and Madhya Pradesh. So this is about the distribution of the sorghum. Next, coming to the progenitor of the sorghum. Generally, we are having the four progenitors in the sorghum. That is, first is sorghum arundisianum. Next is sorghum verticilliflorum. Next is sorghum sudanense and sorghum ethiopicum. These are the four progenitors of the sorghum. And the most important, the wild species are the sorghum bicolor species, that is arundisianum, which is having the chromosome number 2n equal to 20. And next is sorghum halepens, which is having the chromosome number 2n equal to 4x equal to 40. It is a hexaploid. And next is the diploid wild species, that is sorghum arundisianum. This is having the chromosome number 20. Is considered as the mostly it is considered as the ancestor for the cultivated sorghum. So this is about the progenitors of the sorghum. And next, coming to the classification, generally the famous classification is Snowden's classification, which was given in 1936. But later this famous Snowden's classification was refined by the Garber and Doggett Garber in 1950 and Doggett in 1970. They have again refined this classification, that is a sorghum. The sorghum is first divided into two sections, that is section 1 and section 2. In section 1 we are having the true sorghum, and in section 2 we are having the para sorghum, that is the other sorghum. Here you can having the sorghum versicolor, sorghum introns, sorghum purpurosericulum, and next is sorghum intidium and sorghum plumosum. So these are the para sorghum, that is other sorghum. And next is the first section is that is true sorghum. Again, this true sorghum is divided into subsection. The first subsection is Arundisianum, and next one is Helpensia. The first one is Arundisianum. It is a diploid species having the chromosome number 20, whereas Helpensia, it is having the chromosome number 2n equal to 20, as well as some of them are having the 40 chromosome number. So here Arundisianum, again they are divided into series. Here the first series, it is spontanea, that is a grass type, and next is sativa type, that is a grain type. So again they are divided into two series based on the grass and based on the grain type. Based on the grass it is spontanea, and based on the sativa it is a grain type. So in case of spontanea, here we are having the sorghum sudanense, next is sorghum ethiopicum, and next is sorghum virgatum, and sorghum verticilliflorum, and sorghum And next is the series. It was divided into based on the class, it is spontaneous. Based on the sativa, it is green type. So in spontanea, it is sorghum sudanense we are having, and sorghum ethiopium, sorghum virgatum, sorghum verticillifolium, and sorghum stagfi. And whereas in sativa green type, we are having the sorghum vulgare, sorghum suba. Glabescens and sorghum dogma. So this is about the Arundasianum. And next is Hailpinsia. Here Hailpinsia we are having the sorghum hailpins, sorghum millesium, sorghum almond, sorghum propinicum, and sorghum radulfianum. So this is about the refined classification by the Garber and Doggett. The sorghum first they are divided into two sections. That is true sorghum, whereas para sorghum. Whereas in true sorghum again they are divided into subsections. That is Arundasianum, and next is Hailpinsia. And here in Arundasian we are again the subsections divided into two series, that is spontanea, and next is sativa. Here the sativa types are grain types, whereas the spontanea types these are grass types. Grass types they are used for the fodder purpose, whereas grain types are eating purpose for making the flour. So this is about the classification of the sorghum crop. And next coming to the this is the progenitors. So next to the latest classification was again the latest classification was given by Harlan and Dewitt in 1972. So these are the based on the green type they are divided into some five different types. So here first one is the bicolor, which is a widely cultivated one. So in bicolor types they are having their grains are elongate type. Next is glooms are clasping the grain, which may be completely covered, or one by fourth position of the one by fourth part of the grain is exposed. So this is about the bipolar grain type. And next is guinea, that is G. Here the grains are flattened type, dorsoventrally. And next is chordatum. Here the grains are asymmetrical, and the glooms half of the the length of the grain. The glooms are half of the length of the grain. And next is kafir. Here also the grains are symmetrical, that is a spherical type, and the glooms are clasping in the varying length. And next is dura type. Grains are rounded and ovate type, and wedge shaped at the base and broadest, and slightly above the middle, and the glooms are very wide. So these are the five different types which are present in the sorghum, that is a bicolor. Next is gunia, chordatum, kafir, and dura. So here we'll discuss about the most important topic, that is the breeding objectives. So here the first is the grain yield. Generally, for grain type, the yield is more important, and for the forage type, the forage yield is more important. And next is the breeding for non-lodging sorghum. Generally, the height of the sorghum is very tall. So during the heavy winds, the plants will fall on the ground. So to avoid that, we have to develop the sorghum types which are having non-lodging types. And next is dual purpose. Dual purpose genotypes we have to develop, which are having the both grain yield type, which are having both grain and fodder yield. Biomass potential per unit area and early maturity, because early maturity means we can if for fodder purpose generally the requirement is more, so we have to develop the varieties which are early maturing. And next is resistant to biotic stresses which includes the pest and diseases. So here the first diseases like grain mold, which are mostly observed in the sorghum crop, and we can see the downy mildew, rust, leaf blight, and leaf spots. And next is resistance or tolerance to the insects like shoot fly, stem borer, and gallmids. This stem borer, if the stem borer is observed in the sorghum crop, this pest will eat the whole stem, and the entire plant will fall, and the yield loss we can observe in case of sorghum. So these are the major major breeding objectives. And apart from this, here we can also see some of the breeding objectives, that is a resistance to abiotic stresses like salinity and drought with resistance to low HCN content, that is hydrogen cyanide. Generally, we have to select the fodder types which are having the low HCN content. If this content is more, it is harmful to the cows and buffaloes. So we have to breed the varieties which are having low HCN content. And next is breeding for quality characters like bread making. Mostly we use for bread making, and red grain for the biscuit making, and the protein and the lysine content. And mostly the sorghum is used for making chapatis. Nowadays we are consuming the sorghum, that is jowar rotis, because they are having high fiber content, and they are having the low glycemic index, so we are consuming more. And next is breeding for the special traits like sweet sorghum and Saiga resistance. We are also for making the some bread, or for making for chapatis. We are breeding for the sweet sorghums and the Saiga resistance. We can see this. Uh, uh, Taiga, which is mostly in the sorghum crop. And next is to isolate the alternate sources of the cytoplasmic male sterile lines. So these are the main breeding objectives of the sorghum crop, that is a high fodder yield, high grain yield, and the non-lodging types, and we have to develop the dual purpose genotypes. And next is early maturity, and next is resistance to biotic and abiotic stresses. And next is breeding for the quality, for making for the chapati making and for bread making and for the biscuits making. We have to develop the varieties with good quality. And next is breeding for the sweet sorghum and striga resistance, and we have to isolate the alternate sources of the cytoplasmic genetic male sterility lines. Here we are having the combined Kafir CMS line in case of sorghum crop. So these are the most important breeding objectives in the sorghum. And next is breeding procedures. The breeding procedures which are used for the sorghum improvement of two types, that is a general method and special method. Uh, General method we are having here we are having the introduction, pure line selection, pedigree method, backcross method, and composite breeding. Whereas in special method, we are having the if any breeding method is not working out, then only we'll go for the some of the special methods like mutation breeding, descriptive mating, and selection and biparental mating. So these are the two important methods which are used in the sorghum improvement, that is general method and special method. Next is breeding procedures. Here we'll discuss about breeding procedures, that is a breeding methods. The first is introduction. Generally, the varieties of the Millo and Kafir sorghum the varieties of the Millo and the Kafir sorghum are introduced from the USA, and they are used in the conversion program to convert the local long duration photosensitive varieties to the short duration non photosensitive types. And netro selection method, that is old varieties like Co1, Co2, Co4 are the all selection made from the local land races. And next is hybridization and the selection. Here we are having the two different types of hybridization, intervarietal hybridization and interspecific hybridization. In intervarietal hybridization, we can see the three-way cross derivative, that is a code 25, from which are crossed between IS 4283 into code 21. This two are crossed with CS 3541. By crossing this, we have obtained, that is a three-way cross derivative, that is a code 25. And next is code 26. That is code 26. It is a single cross derivative, that is which is obtained from MS 8271, which is crossed with IS 3691. So this is about the intervarietal hybridization. And we can see some of the hybrids that is interspecific. Through interspecific hybridization we can observe that is a core 27 sorghum was obtained, which are crossed between core 11 and sorghum hailpines. And next is mutation breeding. This From mutation breeding, by using the X-ray mutant, they have developed the CSV5, that is 148, and core 19, which is a natural mutant from the core 2. So this is about the mutation breeding. And next is backcross method. Generally, the long duration photosensitive germplasm was converted into photoinsensitive short duration sorghum by using the backcross method, and this was done at USA, and a similar program was conducted at the ICRISAT also. And next is population improvement, by using the cytoplasmic, that is a CGMS system, as well as GMS system. We can go for the population improvement method in case of sorghum. And next is use of apoptotic lines. Some of the apoptotic lines have been identified in breeding program, and by vegetative propagation also we can fix the heterosis in case of sorghum. Here you can see the example, that is R473 from the Hyderabad. And next here you can see the practical achievements of the sorghum. The hybrids are generally developed by using the cytoplasmic male sterility system, and the Kafir 60 is the source of the male sterility in case of sorghum. And the high lysine Ethiopian mutant, that is IS 11167 and 11758, are used for the quality improvement. And some of the high yielding varieties and some of the hybrids we can see in the sorghum. That is first is the hybrids, that is CHS1, CHS2, CHS3 for the Kharif season, and next is CHS7 and CHS8 and CHS12 for the Rabi season. Here we are having the hybrids exclusive for the Rabi season as well as for the Kharif season. And next is varieties, we are having the Swati, CSV1, CSV2 for the Kharif season, and CSW7 and CSW8 for the Rabi season. So these are some of the practical achievements of the sorghum. Mostly for hybrid development, we will go for the CGMS system, that is cytoplasmic generic male sterility system. And here for the source of male sterilities is combined Kafir, that is Kafir 60. And they have developed some of the high lysine Ethiopian mutants that are IS 11167 and 11758, which are used for the quality improvement. And here we are having the some of the important hybrids and varieties for both Kharif season and Rabi season. So next coming to the pearl millet crop, it is also called as a bulrush millet or candle millet, because it is the inflorescence is like a candle type, so it is also called as bulrush millet or called candle millet. And the scientific name of the pearl millet is Pennisetum americanum, and the chromosome number is 2n equal to 14. It is also a diploid species, having a 14 having the chromosome number 14. Generally, this pearl millet is the most drought tolerant crop, and it belongs to the origin is West Africa. And next is distribution. It is cultivated in Africa, India, Pakistan, Southeast Asia, USA, and Europe. Taxonomy. Coming to taxonomy, the genus Pennisetum is having more than 140 species. The STAP in 1954 have divided the genus Pennisetum into 5 sections, that is Gymnothrix, Eupennisetum, Penicillaria, Heterostachya, and Brevivaria. So this cultivated Pennisetum glaucum belongs to the section Penicillaria. So these are the five sections which was where the genus Pennisetum is divided. That is Gymnothrix, Eupennisetum, Penicillaria, Heterostachya, and Brevivaria. Next, coming to progenitors, these are the 3 progenitors which are present in the present in Bajra crop, that is Pennisetum purpureum, Pennisetum cumulatum, and Pennisetum orientale. And next is breeding objectives. Mostly will breed for the high grain yield, and next is breeding for improved grain quality, and breeding for drought tolerance, and breeding for disease resistance, and breeding for alternate source of cytoplasm in male sterile plants, and breeding for high forage type. So these are the 6 important breeding objectives in Basa crop, that is a high yield, and next is improved quality and drought tolerance, disease resistance, and other alternate source of cytoplasm in case of a Basa crop. So these are the most important breeding objectives of the Bajra crop. And next coming to the breeding methods. So here we are having so many breeding methods in case of Bajra. So through introduction method, they have introduced a hybrid Bajra from the Punjab and TIF 23A from the USA. So these are the two milestones which are done through introduction breeding method, that is hybrid Bajra from the Punjab and TIF 23A from the USA. And next is selection, that is pure line selection. Through pure line selection, they have developed the code 2 and code 3. And next is hybridization and selection. Through interspecific hybridization, they have crossed the Pennisetum glaucum and Pennisetum purpurea. They have obtained the Kumbu Naiper hybrids. So this is about the interspecific hybridization. Here the Pennisetum glaucum was crossed with Pennisetum purpureum. So they have obtained the Kumbu Naiper hybrids. So this is about the hybridization breeding method. And next is heterosis breeding. Heterosis breeding is nothing but it is a development of the hybrid Bajra. In the earlier days, before the identification of the male sterile lines, they have utilized the protogynous nature where hybrids were released, and the hybrids were produced by sowing both parents in the ratio of 1:1. Generally, after the discovery of the cesium male sterile line, that is TIF 23A by Burton in Tifton, the Georgia has led to the development of the hybrids. Earlier hybrids of India are HP1, that is hybrid Bajra 1, hybrid Bajra 2, up to 3, 4, and 5. They are produced utilizing this TIF 23A line. So this is about the hybrid. That is heterosis breeding, that is hybrid Bajra. And next is population improvement. The DCRISAT have developed that the WCC 75. It is a best example for the population improvement. This was developed from the world composite by using the recurrent selection method, and it was developed from the derivatives of the numerous crosses between the diverse sources of the germplasm and Nigerian early maturing land races. So they are known as zero millets. And the other example is ICMV 155, which was developed from the also ICRISAT. And next is synthetic varieties. So synthetics are produced by crossing in isolation a number of lines tested for the GCA, that is a general combining ability. So example, you can see ICMS 7703. And next is here you can see it is also a result of cross between 7 inbred lines of India as well as the African crosses. And next is mutation breeding. at New Delhi, that is a TIFT 28 line was gamma irradiated, and 507A line resistant to the downy mildew was evolved. And with this, the hybrid NHB3 was evolved, that is crossed between 5071A into J107. So these are some of the most important breeding methods in case of bajra crop. And next is breeding centers. Here the two centers which are working for this bajra crop, that is ICRISAT, that is International Crop Research Institute for Semi-Arid Tropics, which was located in Hyderabad. And next is All India Pearl Millet Improvement Project, that is located in the Jodhpur, Rajasthan. And practical achievements, here also we are having the varieties and hybrids in case of bajra. Varieties are PSB 8 and PSB 15 and Mukta, and hybrids are HHB 45, HHB 50 from Hissan, and GHB 30, GHB 27 from the Gujarat. This is about the bajra crop. Here you can see the importance of the bajra crop, and next is taxonomy, and here the progenitors and the breeding objectives, and these are the breeding methods of the bajra crop. And here you can see the practical achievements and the breeding centers which are working on the bajra crop. And next, coming to the most important pearl millet, that is the finger millet or ragi. This ragi or finger millet is having high calcium content. It is a high calcium content millet. So mostly nowadays they are consuming this ragi as a they are consuming as a java. So here the scientific name of this finger millet is Eleusine coracana, and is having the chromosome number 2n equal to 36. The common name is the finger millet is derived from the finger like why it is called as finger millet means because the branching of the panicle is like a finger type, like fingers, so it is called as finger millet. And the ragi is derived from the Sanskrit word, that is ragika. And next, here you can see the origin. According to it is this ragi is having the two origins according to two scientists. According to Vavilo, it is Africa, and according to D. Kandol, it is India. And distribution, it is grown in India, Africa, and Pakistan. And progenitors, Elysian indica is wild in Indica. Wild in India, whereas Africa, that is Elysian stricta, is wild in only in Africa. Next is breeding objectives. Here you can see the breeding objectives. These are the six important breeding objectives of a ragi crop, that is high yield. In all the millets, the yield, higher yield as well as higher forage yield is more important. And next is early maturity and better quality and resistant to the diseases and resistant to the pest and resistant to abiotic stresses. Generally, mostly we have to breed for the resistance to abiotic stresses because generally we will grow these millets in the rain-fed conditions. So mostly we will observe a drought conditions. So to avoid all these things, we have to develop the varieties which are having the more drought resistance and more resistance to the abiotic stresses. And next is breeding methods. The first is introduction. Through introduction, Inda 5. Inda 5 is nothing but it is a cross between Indian types and African types. This Inda 5 ragi is introduced from the Karnataka. And next is selection, that is a pure line selection. Earlier, they are all varieties were evolved by using the pure line selection. Next is hybridization and selection. We are in bajra, in ragi, we are having the two different types, African types and Indian types. Generally, the African types are having long fingers, bold grain with stiff straw, and further they are but they are having long fingers and bold grain, but they are photosensitivity and having uneven grain maturity. Because of this, they are not recommended for cultivation in India. And next is Indian types. These Indian types having short fingers, whereas small grains and photoinsensitive nature is there. So these African types are utilized in the hybridization program only to develop the long fingered panicles with disease and drought resistance. So the cross between the Indian type and African cross derivatives are nothing but Inda varieties, which are interspecific. So other state varieties are that are Inda 5 Kaveri, which was crossed with IE 929, that is Inda 9. So here we are having the two different types of two different types of ragi, that is African types and Indian types. The African types are having the long fingers, whereas bold grains, but they are photosensitive. They are having the photosensitivity. So they are not mostly used. They are they are used only in the hybridization purpose for transferring this long grains with the bold grain types, and the Indian types are having the short fingers, small grains, and photo insensitivity. So the cross between these African types and Indian types are called end of types. Next is heterosis breeding. This artificial induction of male sterility through use of the gametocides, that is GA3 to 4DR, being attempted in case of ragi. And next is mutation breeding, that is T20 mutant from AKP7. And next, coming to the practical achievements, here you can see the varieties like Sarada, Kalyani, Simhadri, Padmavati, Ratnagiri, Godavari, and Gautami. So these are the most important varieties of the ragi crop. So next, coming to the sorghum of all these millets. So first is the sorghum, that is a sorghum. It is a scientific name is sorghum bicolor, having the chromosome number 20, and it belongs to and it was originated in Ethiopia and widely grown in the Africa, India, China, and USA. And the breeding mostly focuses on the yield, that is a panicle size and green white, and whereas the quality it is on the protein and lysine content, and resistance to the disease like downy mildew, rust, and ergot, and pest are the stem borer, shoot fly, and midge. And the hybrids developed are there are so many hybrids which are exclusively developed for both kharif and rabi seasons by using the cytoplasmic sterility line. So this is about the sorghum, and next is bajra, that is a pearl millet. So the scientific name is Penicillium americanum araglochum. It is having the chromosome number 14, and the origin is West Africa, and is mostly grown in the India and Africa. And the breeding mostly focuses on the high yield, drought tolerance, disease resistance, and forage value. And the hybrid Bajra was evolved by using the cytoplasm male sterile line, that is STIFT 23A. And next is ragi and finger millet. It is the scientific name is Elysian coracana. Chromosome number is 2n equal to 36. So it is the origin is Africa and India, according to two different scientists, according to Vavillo and according to Decandol. And next is the breeding is mostly focuses on the high yield, early maturity, drought, and disease resistance. And India varieties are developed by crossing between the Indian types and African processes.